In this video, we want to work on all problems of AMC 8 2024. I will leave 24 homeworks from AMC 8, 10, 12 AMY, USAMA, USAJMO, SUMAC, prestigious summer camp for Stanford University, Promise for Boston University, again prestigious summer camp, BMO round 1, I can say the most two prestigious national exams, Olympiad national exams, are for USA and UK. For UK, it is BMO, British Mathematical Olympiad, and BMO round 2. Okay. During solving the problems, I will leave 24 homeworks. We will solve all problems. And for each problem, I will tell you homeworks and ideas are what, background ideas. You can work on these 25 problems here. And also, I will tell you 24 important background ideas during solving the problem. For example, units digit, last 2 digits, last 3 digits, this rule in modular arithmetic complement rule. These 3 identities, we have around 5 identities that you should memorize. Case for triangle inequality, write all cases, translation, replacement, shoelace theorem, paths, BFS. It's more related to informatics, but sometimes we see this idea in Math Olympiad exams. And when we have these numbers, for example, an minus 1, a1, a0, it is similar to this. Considering range, especially useful for full solution exam. If sum is constant, product is maximum when what? Venn diagram, when the numbers are near to each other. Venn diagram, Pythagorean theorem, diagonal that passes through how many unit squares in a grid. Famous form of two numbers. When we consider GCD, split a figure into smaller parts, and complement rule. Okay, so if you wanted to learn more ideas or want to solve more similar problems, feel free to send message to my WhatsApp number in the description. Problem 1, 2024 AMC 8 problems. What is the ones digit of this number? One way is to calculate this one completely, but because it says ones digit, we need to only focus on ones digit of each number. So it will be 2 minus 2 minus 2 minus 2 minus 2 minus 2. 1, 2, 3, 4, 5 negative 2's. This one will be cancelled, so it will be negative 8. And because it is negative, if you know mod, you can add 10, because ones digit means the remainder when divided by 10. So if you add 10, negative 8 plus 10 is 2. You should consider mod 10. Okay. So the answer will be which choice? The answer will be choice B. Now for modular, let me tell you some homeworks that you can solve. Okay, if you want to get good at modular arithmetic, you can try this problem of AMC 1012 2022 10B, problem 25. It is also in 12B, but not problem 25. If you try to solve this, you will get good at modular. And let me tell you some rules in modular. For example, one thing that you should know is units digit is mod 10. Units digit or ones digit. You should consider mod 10. If you want to consider last 2 digits, you should consider mod 100. If you want to consider last 3 digits, in AMY we had a problem related to this. AMY 2021, mod 1000. But that AMY problem is harder than this. And in modular, you should know modular arithmetic. In my previous videos before the exam, I solved an AMY problem. In that problem, I explained a lot of things for modular arithmetic. So we have some formulas. For example, division, when we have AB is congruent to AC mod M, you can divide both sides by A, and then we can say B is congruent to C mod M over GCD of M and A. Okay, you can have these 4 ideas and you can try this one as homework 1. If you wanted, I can tell you another problem I released in my previous videos, AMI problem, which is a bit harder than this, but then you will get good at modular arithmetic. Okay. Now let's try problem 2. Problem 2. What is the value of this expression in decimal form? So this one. We should simplify as much as we can. So if we divide by 11, it will be 4, and here we can cancel that. If we divide by 11 first, it will be 10 by 11, 4. Then again, we can divide by 2. We can cancel 2. It's 5 over 2. Here, you can divide by 11. It will be 4. If you divide by 11, it will be 100. If you divide by 4, it will be 1. And here, it will be what? It will be 25. So, we have 4 plus 5 over 2 plus 1 over 25. It says decimal form. So it will be 4 plus 2.5, 1 over 25. We can multiply by 4. Or we can write like this, 4 over 100. 0.04. So it will be what? It will be 4 and 0 plus 5, 5. 4 plus 2, 6. 6.54. So the answer is choice C. Now let's try problem 3. So in problem 3, the figure is this one. Let me show you this one. Okay. Read this problem first on your own. It says this one is 4, this one is 7, this one is 9. Length of this is square, and this one is 10. So we have 4 squares like this with side lengths 4, 7, 9, and 10 units. And then we should calculate area of shaded region. Area of this shaded region is area of this square minus area of this square. So it will be 7 squared minus 4 squared, which is 49 minus 16. It will be 33. In next step, we should calculate this area. Again, this one is area of this square minus area of this square. We want to use complement rule. So it will be idea 5. Complement rule. So it will be 10 squared minus 9 squared, which is 100 minus 81, which is 19. And if we calculate, the answer is 33, this shaded region, plus 19, this shaded region. It will be 1252. So the answer is choice E. Next one, problem 4. It says when we have all integers added 1 through 9, then one number is left. Her incorrect sum turned out to be a square number. Which number did Yunji leave out? So it means that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We don't know that 9, all one-digit numbers. So suppose the number that we don't have is x. Okay. So we have 1, 2 to x minus 1. We don't have any x. We have x plus 1, 2, 9. And the sum is perfect square from assumption of the problem. Perfect square. Now what can we conclude? We can say, okay, left-hand side is what in terms of x? It is 1 to 9 minus x because we don't have x. It is a perfect square. Okay. Idea 6. We have some identities before the exam. I said they are important. And you should memorize. One of them is 1 to n. One of them is 1 squared to n squared. Let me write n times n plus 1 over 2. Idea 7, for example, you should know 1 squared to n squared. It will be n times n plus 1 times 2n plus 1 over 6. Next idea. There are around 5 ideas, 5 identities that you should memorize. And they are so much important. And also in AMC 10, 2023, it was useful as homework 3, one problem of AMC 10. 2010A, 2023. It was something like, let me tell you, it is exactly which problem. Exact problem is, let me paste it. Let me open the page, okay. So you can solve this one. It is AMC 12, 2023. It is similar to the previous one. You should know how to work with identities. For this one also, let me tell you another homework. How many homeworks? How I told you homework 2? Homework 3. I wanted to say one problem with identity. It was AMC 12. You can do this one as homework 3. As homework 4, you can solve a similar problem to this problem shaded region. It is for AMC 10, A 2023. Let me tell you exact problem is what? 2023 is this one. You can try this one. It is exactly similar to this problem 3, but here we have circles. Here we have squares. Okay, so now let's calculate this part. 1 to 9. We should use identity 6. It will be 9 times 10 over 2 minus x. 9 times 10, 90 over 245. 45 minus x should be perfect square. And x is from 1 to 9. So 45 minus 1, 44, it's not good. 45 minus 2, 43, not good. Until 45 minus 9, 36. And if you check all these numbers, only 36 is perfect square. So we can conclude x is what? X is 9. So correct choice is what? Choice E. It was problem 4, and the homework related to this one is this homework. Homework related to problem 3 is homework 4. Okay, problem 5. It says Alia rolls 2 standard 6-sided dice. She noticed that the product of the 2 numbers rolled is a multiple of 6. Which of the following integers cannot be sum of 2 numbers? Okay. For this one, I told you how many ideas? 8 ideas. So, idea number 9, casework. That is so much useful in AMC problems, AMC 8, 10, 12, and also AME. So here, what can we say? We can say, okay, in case one number is 6, because when the product is multiple of 6, we can have 6 in, for example, one of them can be 6, and the other one can be any number, 6, 1, 6, 2, 3, 4, 5, 6. It is case 1, case 2 is what? Suppose we don't have 6, so one of them should be even, one of them multiple of 3. So the cases, it's not important which of them is even, which of them multiple of 3, because at the end we should work on sum. So you say, okay, the first one is 2, 4. It's 6 not possible because we check 6 in case 1. The next one can only be 3. Okay, so in these cases, the product is multiple of 6. Also in these cases, it will be multiple of 6. Now let's consider the sum. 6 plus 1, 7, 6 plus 2, 8, 6 plus 3, 9, 6 plus 4, 10, 6 plus 5, 11, 6 plus 6, 12. Here in this case, the sum is what? 2 plus 3, 5, 4 plus 3, 7. So, A5, we have 5, so we can reject this because it just cannot be. 6, we don't have 6, so the answer is 6. Let's check other choices. 7, here we have 7, 8, and 9. Okay? So the answer is choice B, and we solved it by simple casework. Okay, you can solve 2 problems of AMC 10, 2022 related to casework. So how many homeworks did we have? 4 homeworks for casework if you want to get good at this. Homework 5. Try AMC 10A 2022. Question number what? Let me tell you. Question number 19. And also you can solve homework 6, AMC 10B 2022. Let me tell you the problem was what? Can be 19. Here 19 is for 10B. For 10A, you can try problem 24. Okay. These two problems are two good examples of casework, and you can try them. Okay, problem 5. Problem 6. Sergey skated around an ice rink gliding along different paths. The gray lines here, these gray lines. I'll put this one here. Okay, the gray lines in the figures below show 4 of the paths labeled P, Q, R, S. What is the sorted order of the 4 paths from shortest to longest? Here we can say, okay, if let's compare, for example, P and R. Okay, we can see that for R, instead of considering this one, we consider this length, and it is the distance, shortest distance from 2 points is that you connect them. So this one is smaller than this one. So here, if we consider this one, the difference of P and R are this part and this part. Here we have this one. So P is better than R. So can we reject? So P is before R. Can we reject any choice? We can reject E. We can, sorry. R is before P, I meant. I said this one is smaller than this one. So R is less than P. So we can reject R before P. We can reject C. And at the end, I will explain completely the order is what. So let's first reject choices. R is before P. We can reject this one, this one. So between D and E, we should select. So in both of them, R is the smallest one. So S and P, here P is better than S. This one S better than P, is smaller than P. Let me compare these two things. So this part and this part are in both of them same. Okay, so let's consider this one A, this one B, this one C, this one D. Okay. If you consider the difference between P and S, what can we say? We can say in P, instead of AB, we have AD. Okay. And instead of CD, we have BC. So we should see what, if we want to consider P and S, we should see AD plus BC is greater or AB plus CD. AB plus CD. Which of them is greater? So for this one, you should apply triangle inequality. So it will be which idea homework 6, idea 9, idea number 10. Triangle inequality. So triangle inequality is what? If you have a triangle like this, for example, A, B, C. It is A, it is B, it is C. We know that B plus C, sum of each two sides is greater than A. Also, for example, A plus B is greater than C. A plus C is greater than B. We call it triangle inequality. Now I want to use this to solve the problem. I consider that if intersection is equal to E. Okay? So, AD plus BC. Instead of AB, I write AE plus EB. AE plus EB. Instead of CD, I write. So, I consider, let me write with green, I consider these length equal this part. I split into AE, EB, and these things. AE, EB, instead of CD, I write CE plus ED. This part is pink part. This one is green part in this figure. Now I want to see pink part is greater or green part. And you can use triangle inequality. As you can see, AE plus ED is greater than AD. Let me tell you, AE plus ED by triangle inequality is greater than AD. And also EB In triangle AED, first one. Now in this triangle, EB plus EC is greater than CB. EB plus EC is greater than BC. So we can conclude right hand side is greater than left hand side, and we can say which one is better. This one. So AD plus BC is smaller. So P is before smaller than S. So we can reject E, and the answer is D. But we solved this problem completely. We proved R is less than P. We proved P is less than S. Now I want to prove also S is less than Q. Okay? So let's prove this part together. Okay, so we want to prove what? We want to prove that S is better than Q. So let's prove it. S is better than Q or smaller than Q. How can we prove this? So we can consider this one is A. From the figure, we consider same points like this. So here we said ADCB. ADCB. And then here, again, we can say it is B, it is C, it is D. Okay. So if we consider both things, we can consider, for example, this one is center. If we connect points, we can say we have this one, AB. Okay. Now it is green part, but let me erase it. We consider this one center. This one center. Green part is this part, green part, and now pink part again. Here we consider this part, this part, this part, and this. We can call this one E, for example. We can call this one F, and let's consider, because we had E in previous part, let's consider it is F, it is G. Now I want to see pink part is what? AF plus FD plus CG plus GB. This is pink part. Green part is what? AB plus C. We want to see which of them is great. Let's consider intersection is E, okay? And by the figure, we can conclude if it is midpoint. We prove for midpoint, but if it is not midpoint, we solve the problem here. Let me tell you, if it is midpoint, you can prove this. If it is not, you can prove with other ways. Okay, it depends on the problem. Let's prove one part together. If we call this one E, the green part. So let me call this one E. Instead of AB plus CD, I write what? I write AE plus EB plus, like previous part, CE plus DE. And this part. I want to see which side is greater. Okay. So AE is smaller than AF. Why AE is smaller than AF? The reason is what? By Pythagorean theorem, it will be idea what? Idea 11. Idea 11. Pythagorean theorem. AF is, if you apply this, how can we prove AE is less than AF? Try first on your own. We can say here what? We can say AF is AF squared is AG squared plus GF squared. AE squared is what? Is again AG squared plus G squared. Because G is less than GF, so this part is less than this, so A is less than AF, okay? Now, similarly, we can say what? FD is greater than what? FD, this pink part, is greater than DE, okay? D. CG is greater than what? It's greater than C. And last part, GB is greater than what? GB is greater than B. So 1, 2, 3, 4. So if you consider each term with corresponding terms, you can say that this part, left hand side, is greater than right hand side. So we can say pink part is greater than green part. So we can say Q, length of Q is greater than length of half S. Okay, so we proved also this part. The answer is choice D. Problem number 6. Okay, problem 7. The 3 by 7 rectangle is covered without overlap by 3 shapes of tiles. This, and this. 2 by 2, 1 by 4, and 1 by 1 shown below. What is the minimum possible number of 1 by 1 tiles used? Okay. How many cells do we have in our main table? 3 times 7, 21. Okay. I want to see, so when I want to minimize this, minimum number of these, so I should maximize using these two tiles, okay? So we can say what? We can say these two tiles can cover at most how many cells? Let me tell you, because we should consider range, one part is with example, one part is with proof. Okay, for example, let's try to use one example. Let me copy this one. Okay, let's use an example. For example, I used this one, 4, 4, 4, and 2. So we should fill these 5 cells with 1 by 1. So we can say answer is at most what or at least what? Because it says minimum, we found an example with 5. So answer is 5, or maybe we can find a better example. Answer is less than 5. So we can say answer is less than or equal to 5 by example. Now we want to prove. That, for example, answer is at least 5. If you check lots of examples, you will see, okay, you cannot find a better example than 5, and we can say, okay, answer is 5 probably. And the answer is 5. But we want to prove, because maybe if it is, for example, a problem of full solution exam, like USAMO, you have to prove. And if you write this part, you will get, for example, maybe 10%, at most 10% of the solution, okay, 10% of the mark. Also, sometimes, for example, good exam is hard to find. It's hard to find good example. So if you prove, then you can find correct choice, okay? So let's prove that why the answer is at least 5. I want to prove this part, okay? We have 21 cells, and as you can see, these cells are multiple of 4. So the number of cells that can be covered with these two files is 4K. So because it is 21, with this one, 4K can be 20 or 16 or and so on. If it is 16 or less than that, so we can say answer will be at least 5, because 21 minus 16 is 5. If we can cover 16 cells by these two tiles, 5 cells are left for this. So for 60 and these things, it will be okay. We should only reject 20. We should prove that it is not possible to fill 20 cells with these two tiles. So let's use contradiction. Suppose 4K is equal to 20. It means that we can tie 20 cells with these two tiles. So how many cells are left for this 1 by 1? So by this one, 2 by 2, and 1 by 4, we can cover 20 cells, and by 1, we should cover only 1 cell. See, let's check, is it possible or not? If we consider each row, we want to see we can cover how many cells at most by using these two tiles. If you see, this tile selects 2 adjacent cells. This tile selects 4 adjacent cells. So we can select 2 or 4. But here, how many cells are there? 7. So we cannot cover all these 7 cells by using only these two tiles, because they select only even number of cells. They can select from, for example, here 0, or 2 of them, or 4 of them, or 6 of them. But here we have 7 cells, so 1 cell is left that it cannot be covered by these 2 cells. So this one and this one. So we can see that the answer is at least 3. But here it's not possible to be 1. Okay, so we've reached contradiction for this one. So 20 is not possible, so they can cover at most 16. So the number of cells that should be covered with 1 by 1 will be at least 21 minus 16, which is 5. Okay, this part, I can say this part, proof of this part of this problem was the hardest part of this AMC exam. Okay, part of AMC 8 2024. It was the hardest part if you want to prove this. So it was not easy at all. If you couldn't understand, you can watch video again. And if you had any question, if you wanted me to explain more, feel free to send message to my WhatsApp number in the description and comments. And also, I can tell you similar problems, lots of other problems that are related to this from USAMO Full Solutions Exam, AMI, BMO, the most prestigious national exam after USA AMC is BMO. It's for UK, and you can solve these types of problems. Okay, so let's select the answer. The answer is which choice? Is choice E. Problem 8. On Monday, Tay has $2. Every day, he either gains $3, or so we have plus 3 every day, or multiply by 2, or doubles the amount of money he had on the previous day. How many different dollar amounts could Tay have on Thursday, 3 days later? So Monday, Tuesday, Wednesday, and Thursday. So at first we have what? We have 2. Next day we can have what? Let's write this. Plus 3, 5, or multiply by 2, 4. Then next day, plus 3, 8, multiply by 2, 10, plus 3, 7, multiply by 2, 8. Now last step, plus 3, 11, multiply by 2, 16, plus 3, 13, multiply by 2, 20, plus 3, 10, multiply by 2, 14, plus 3, 11, multiply by 2, 10. Okay, so our numbers, let's sort them. 10, the problem wants what? It says how many different dollar amounts. So 10, we've considered 11, we've considered 13, 14, and 16, and 20. Okay, so how many different values are there in this problem? 1, 2, 3, 4, 5, 6. So the correct choice is what? Is choice D, which is 6. Okay, so again we can consider we solve this problem. We've written all cases. For this one, you can call it idea 11. You should write all cases in many problems of also AMC 8, 2023, 2022. You can check my website, and in my website I added some similar problems, okay, in AMC 8, 2023 and 2022. We had some cases, some problems. You should write all cases, and it will be homework 7. Okay, now it was problem 8. We solved this. Now let's try problem 9. Okay, problem 9. all of the marbles in Maria's collection are red, green, or blue. Maria has half as many red marbles as green marbles. Okay, so we can say R is equal to 1/2 times G. Next one. So this one is related to, you should translate a word problem into equations like this. So it will be idea what? We had idea 11, idea 12. So here, translation from a word problem to equations. And we had similar problems in my website. If you check homework 7, homework 8. Again, you can see similar problems in my website, mathgoldmedalist.com, for AMC 8, 2022 and 2023. Okay, there are around, as I said, 40 ideas, 40, 50. If you want to learn them, feel free to send a message to my WhatsApp number in the description. Okay, it says, and twice as many blue marbles as green marbles. So B is equal to 2 times G. Which of the following could be the total number of marbles in Maria's collection? So you have only red, green, and blue. So it says R plus B plus G can be what? Here we should use replacement. Idea 13. So much important. And as homework 9, you can solve one problem from Amy 2023 only by applying replacement. Let me tell you exact problem is what. You can try this problem of Amy, this one, Amy 2 2023, as homework. You can solve it only by applying replacement, like here. R is 1/2 times G plus B is 2G plus G. So it will be 1/2 times G plus 3G. So if you use common denominator, it will be G plus 6G, 2 times 3. G, so 7G over 2. So we can conclude what? Our number should be multiple of 7. Because here numerator is multiple of 7 and in denominator 2 is relatively prime 7. So it should be multiple of 7. So which choice is multiple of 7? The only choice that is multiple of 7 is E. So the answer is E. Also, we can say it's somehow related to invariant. Okay, if you want to solve invariant problems in SUMAC, Stanford Summer Camp, so much prestigious and good for your CV, is SUMAC 2022. I think 2 or 3 problems of that can be solved with invariant. Okay, when you, for example, say, okay, here it has to be multiple of 7. Okay, so if you want to know those problems are what, I should check it. Feel free to send message to my WhatsApp number in the description. Also, in BMO round 2, British Mathematical Olympiad, let me tell you exact year is what, 2023. One problem is related to, it has some actions and you should use them. I can say after AMC, the most prestigious national exam is for UK, BMO round 2, round 1. One problem, I think it was Q2 or Q3, Q2 90%. And homework 12, if you want to solve more invariant problems, we have again one BMO 1 problem, 2019. Some children are around the circle. And I don't remember the exact problem was what. I can check. So if you want to know exact problems or what, as I said before, feel free to send message to my WhatsApp number in the description. So we solved homework problem 9. Problem 10. In January 1980, the Mauna Loa Observatory recorded carbon dioxide level of 338 ppm parts per million. Over the years, the average CO2 reading has increased by about 1.515 ppm each year. What is the expected CO2 level in ppm in January 2030? Round your answer to the nearest integer. Okay, so from 1980 to 2030, how many years are there? 30 plus 20, 50 years. And in each year, for each year, we should add 1.515 ppm. So at first, initial value was this. After 50 years, after each year, increasement is 1.515. So it will be what then? You can say 338 plus 5 times 15.15. You can apply this 0 here, and then this decimal point goes here. So it will be 338 plus 5 times 5, 25. We have 2. 5 times 1, 5 plus 2, 7. And again, point, again, 75. So if we add, it will be 5, 7 point. 5 plus 8, 13. We have 1. 5 plus 3, 10 plus 1, 11. We have 1. And 1 plus 3, 4. So if we round the nearest integer, it will be 414. So the answer will be which choice? Choice B. Problem 11. The coordinates of triangle ABC are 5, 7 here, like this figure. 11, 7, 3y with y greater than 7. So because y is y coordinate of C here 7, 7, so we can conclude C is on top of this line. Because this line is what? Y equal to 7. This line. And the area of ABC is 12. What is the value of y? So area of this triangle is what? Height times base over 2. So if we extend this, let me extend with this line. And if we draw altitude, it will be what? This length is what? Y coordinate is y here, and this line is horizontal line because both of them are 7. It is a special triangle, but if you, for example, had general triangle, you can use, let me tell you, it will be what idea? Idea 12. Okay, idea 13. For finding area of, for example, general polygon, you can use shoelace theorem. Okay, or shoelace formula. If you want to know that, if you want to know how to apply this, I want to learn other ideas, as I said before, feel free to send message my WhatsApp number in the description. Okay, so this is y, this is 7. So this length is y minus 7. Height times base over 2. Because it is horizontal line, it will be 11 minus 5, 6. So area, the problem says it's 12. It is equal to y minus 7 times 6 over 2. 2 and 6 you can cancel 3. 3 you can divide both sides by 3/4. So 4 is y minus 7. So if you add 7 to both sides and switch left hand side and right hand side, it will be 11. So the answer will be which choice? The answer will be choice D. There are some general formulas in coordinate geometry, distance of a point from a line, point from a plane, and also I can say, for example, sometimes how to relate coordinate geometry to probabilities. If you want to learn all these important approaches, as I said before, feel free to send message my WhatsApp number in the description. Problem 12. Rohan keeps a total of 90 guppies in 4 fish tanks. First one, there is one more, so we have 4 tanks. Let's consider first one, second one, third one, for example, fourth one. And let me move them to left. Okay. Suppose first one we have A1 guppies, A2 guppies, A3 guppies, A4 guppies. Again, here we should use translation, okay? A word problem into equations or inequalities in math. So from first one, there is one more guppy in second tank than in the first tank. So A2 is A1 plus 1. Second one, there are 2 more guppies in the third tank than in the second tank. So A3 is A2 plus. Last one, there are 3 more guppies in the fourth tank than in the third tank. So A4 is A3 plus 3. How many guppies are in the fourth tank? And we know that the problem says Rohan keeps a total of 90 guppies. So we can conclude A1 plus A2 plus A3 plus A4 is 90. Okay. Again, this problem we should use like previous problem. These ideas are background ideas, and in, for example, 1 year, we have more than one problem from one of them. Replacement, and here A1 is A1 plus A2 is what? A1 plus A3 is A2 plus 2, so A2 is A1 plus 1. So if I replace A2 with A1 plus 1, it will be A1 plus 1 plus 2, A1 plus 3. And again, A3 plus 3, we know A3 is A1 plus 3, so you can write A1 plus 3 plus 3, which is A1 plus 6. So here, replace all terms in terms of A1. For example, A3 is A1 plus 3. And A4 is what? A1 plus 6. Okay, which is 9. So 1, A1, 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 A1. 4A1 plus 1 plus 3, 4 plus 6, 10 is equal to 90. If you subtract 10 from both sides, 4A1 is equal to 80. And if you divide both sides by 4, A1 will be equal to what? 20. So the problem says what? Fourth tank is what? So A4 is what? A4 was what? A1 plus 6. A1 is 20. Here we reach 20 plus 6, which is 26. Okay. So we had similar problems in AMC 8, 23, 2023, 2022. If you go to my website and check feature similar problems, and in the problems that we have, for example, translation, you can solve similar problems. So for this problem, problem 13, Buzz Bunny is hopping up and down a set of stairs one step at a time. In how many ways can Buzz start on the ground, make a sequence of 6 hops, and end up back on the ground? For example, one sequence hops is up, up, down, down, up, down. Up, up, down, down, up, down. So here, how many steps are there? It says 6 hops. Okay. And one important thing that you should pay attention, for example, in first step, you cannot select down because it cannot go under the ground. Okay, so again, idea of this problem and also previous problem, we had casework, and before the exam, in my videos, I said casework is important. Also before AMC 10 and 12, I released some crash courses, and in those videos, I said casework is important and we solve similar problems. Okay, so here, if you consider the first action is up, it's casework. Then second action is what? It can be U or D. Okay, so let's consider U or D. Now after this part, third action can be U or D again. If we have 3 U's, then we should have 3 D's, because at the end we should reach here. So one case. Now again, for this part, UUD. Next one is what? Is U or D. So again, if you have 3U's here, we should have DD in this part, one case. Now in this part also, because it is like this one, then next two actions should be UD. One. Now here, U down. Next one, because it goes here and here, next step we should select U. For next step, we can have U or D. That's right. In this case, we have 3U's. In total, we should have 3D's and 3U's. So when we have 3U's, we should have 3D's here. Last two should be D. Now it will be what? One case, and this part UUDD. So it means UD. Here, last two steps should be U and D. So the answer here also, it will be 1, and the answer will be 1, 2, 3, 4, 5. It will be choice B. We have 3 ideas in paths. Let me see how many ideas have I told you. Idea 13, idea 14. We have three ideas in paths. 95. This one was not a path problem. It was more casework problem. But we have three main ideas. Placing numbers, second one permutation, third one labels. And I can say 90% of the problems related to paths can be solved with one of them. So let me write placing numbers, second one permutation, last one labels. If you want to learn this idea and solve related AMC, AME problems, AMC 8, 10, 12 problems in all years we have. In all grades. If you want to learn that, feel free to send message, as I said before, to my WhatsApp number in the description. Problem 14. The one-way routes connecting towns AMCXYZ are shown in the figure below. The distances in kilometers along each route are marked. Traveling along these routes, what is the shortest distance from A to Z in kilometers? So for these types of problem, we can use one idea. Let me tell you, it will be which idea? Idea 14, idea 15. We can call it BFS. For finding shortest distance, this one is useful. I will explain. It means what in general graph, but also in directed graph. You can apply special cases of that. And after this, I will tell you also homework that you can solve it with BFS to get good at this side. Okay, let's start. Here, when you want to solve these types of problem, you say, okay, at first we are in which vertex, or for example, which town? We are in A. And the distance from A to each of them, from A to A is 0, okay, the distance. Now we update one by one. So A is connected to which of them? It's directed to which of them? X and M only, okay, so. But X, if you consider input to X, if you want to reach X, you have to pass from A. Okay, so next one that you should update is X, because we've considered A, and now next step X. So because it was 0, for X it will be what? 5, because 0 plus 5 is 5. The distance is 5. Okay, and also for X it is easy. You can say, okay, minimum shortest distance is 5. Then for M, what are the choices for going to M? From here and here. We should check both of them to select the minimum. If we go from here, it will be 5 plus 2, 7. If we go from here, 0 plus 8, 8. Which of them is smaller? 7, 5 plus 2. So M is 7. Okay, now, in next step, if you want to, for example, fill C, because you can go from Y to C, and we've not added Y here, so we should fill Y first. From Y, if you consider Y, from X and M, you can only go to Y. So if you check 5 plus 10, 15, 7 plus 6, 13, it is better. So Y will be 13. Okay? Now for C, what are the choices for going to C? This one and this one. 7 plus 14 is 21. 13 plus 5 is 18. So it will be 18. Z is 18. Now let's check Z. 13 plus 17, 30. 18 plus 10, 28. And this one is what? 25 plus 7, 32. So 32, 28, 30. Which of them is better? Obviously 28. So Z is 28. And the answer is 28, which is choice A. Now let me also tell you something. We can find the path is what? 28. How we reach 28? I want to see, for example, the path is what? We solved the problem completely, but I want to see how we should go to reach Z and with distance 28. So how we selected 28 for Z? 18 plus 10. So from C, we went to Z. How we said it is 18? 13 plus 5 was 18 from Y to C. How we reached from Y? We reached to Y. 6 plus 7, 13 from M. How we reached M? We said 0, 8, 5 plus 2, 7 from X and from A. So the path is this pink path. This one, then M after M, Y after Y, C, and after C, 10. And let's consider 5 plus 2, 7, plus 6, 13, plus 5, 18, plus 10, 28. Now let me tell you a similar problem. I-17 homework. It will be which homework? I told you lots of homeworks. Let me check. Homework, homework, homework. Homework 12, homework 13. Homework 13 is what? Suppose we have, for example, it is a problem of Olympiad exam of some country. You have a 6 by 6 table, and they define a movement like knight in chessboard. We want to find maximum distance is what? So, problem is what? You are in A, and movements are similar to knight in chess. It means what? You can go, for example, 2 to one direction and 1 to a direction perpendicular to that. For example, if you are here, you can go to this one, 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 and this one. You cannot go outside the table. So in general, you can have 6 movements. But for example, when we are in A, we can go only to this one and this one, okay? Because 1, 2, or we can say 2, 1, 2, 1, okay? Now it says, okay, if you consider distance of each point by this action, distance of each cell to A, what's the maximum distance? So for example, look, for A, you can say 0 like BFS, these two are 1. Okay, only 2 cells that are 1, the distance is 1 are these. So you should fill this table by BFS, by the things I told you in each step. You should update the cells to reach maximum distance. Okay, if you want to solve similar problems or want to learn idea completely solving similar problems, as I said before, feel free to send message to my WhatsApp number in the description. Problem 15. Let the letters FLYBUG represent distinct digits. It's important that they should be distinct. And then suppose FLY is the greatest number that satisfies the equation 8 times FLY is equal to BUG. What is the value of fly plus bug or FLY plus BUG? Why we write these on the lines? Because when you have, for example, FL, you know that it is a number. But if you write FL, it means product, F times L. But here, for example, it is L plus 10 F, okay? That's the reason we should, when we want to represent number in terms of variable, we should draw these underlines. Okay, so if we consider this one, we can say something. We can say it is F L Y 000 plus FLY. Why? Because, for example, suppose we have 693, then it is 693,000 plus 693, okay? And then you can say it is 693 times 1000 plus 693. And you can factor from 693, it will be 693 times 1000 plus 1. So it will be 693 times 1001, okay? So if you do the same thing, it will be 8 times FLY times 1001, and also for right hand side BUG again times 1001. You can cancel, so you can reach 8 times FLY is equal to BUG. And the problem says what? The problem says greatest number FLY. So if you want to increase FLY should be maximum, because this one is FLY times 1001. So if FLY is maximum, BUG should be maximum. Now, BUG is multiple of what? Multiple of 8. So, maximum multiple of 8, that is a 3-digit number, is what? 1000 is multiple of 8, but it's 4 digits. So if you subtract 8, 992. But we have two nines. The problem says all digits should be different. If you subtract 8, 984. So if BUG is 984, then FLY will be what? We should divide it by 8. It will be 1, 2 times 8, 16, 24, 3. And as you can see, all these 6 numbers are different. Because all these 6 digits are different, so it satisfies and it is maximum. Now, this idea, let me tell you, it will be what idea? Idea splitting BFS. Idea 16. That you have some numbers, you should relate it to 10 to the power of something. You have repetition. For example, you write an minus 1, a1, a0, and you say, okay, it is a0 plus 10a1 and so on to 10 to the an. Okay, and pay attention, we consider unit digit a0. And we have similar problem. Let me tell you, homework 14. This problem is much harder than this, but with same idea you can solve it. It is for promise. It is one of the most prestigious summer camps like SUMAC or Boston University and Promise 2022 first problem, Q1. You can solve with this idea. If you want hint or want to solve similar problems, want to get good at these ideas, as I said before, feel free to send message to my WhatsApp number in the description. Okay. It was problem 15. Let me tell you exact problem is what homework 14. Promise problem is this one. Okay, you can try this one as homework and get good at these types of ideas. It is so much helpful. Okay, problem 16. Min enters the number 1 through 81 into the cells of 9 by 193 in some order. She calculates the product of the numbers in each row and column. What is the least number of rows and columns that could have a product divisible by 3? So, for example, if in a row we have a number multiple of 3, for example, 3, 6, or 9, then that, for example, in a column, that column, the product will be multiple of 3, okay? So, if you want to decrease, because it says least number of rows and columns that could have a product divisible by 3, we should distribute 3, for example, 6, 9, with distances or all of them together in a part. You can guess that if they are near to each other, it will be better. Because when, for example, 3, 6, 9, for example, 12, 15, 18, then this column is bad because of 3, then 6 again makes this column bad, okay? Repeated columns. So it's better to consider them near each other. Okay. And another thing as intuitive thinking. Another idea, let me tell you, it will be which idea? Idea 17. When the problem says find minimum or maximum of something in problems related to combinatorics, you should consider range. Okay, it means what? You should say the answer is at most at least what? What part? One part is with example, one part is with proof. Can you tell me which part is with example? This part. Because if you find an example, for example, that the answer is, for example, 12, then you can understand the answer is 12 or better than this. And this part is with proof. Okay, when we solve the problem, you will understand this idea better and so much important also in use sum of problems, especially in full solutions exams. So, because we want these numbers be near to each other, how many numbers are there? 3, 6, 9 multiples of 3. 281. How many numbers are there? Number of multiples of 3. It's 81 over 3, which is 27, okay? So if we fill one 5 by 5, this one, let me copy this, okay. So if you have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. If you fill all these things, all these cells with multiples of 3, then we have how many multiples of 3? 27. Here, how many 5 by 5? 25. 2 multiples of 3 are left. So if you select this one, then how many bad columns are there? Bad columns means columns that the product are multiple of 3. 3, 4, 5, 6. How many bad rows? 1, 2, 3, 4, 5. 5 plus 6, 11. By this example, we found an example that the answer, and it is not important, the rest are what? Answer is at most 11. So it is 11 or better than this because we found an example with 11. The problem says least number of this, minimum number of this. So the answer is 11, or we can have a better example. Now I want to prove this part. That why the answer also is at least 11. Let me tell you how can we prove this. Suppose that our multiples of 3 are in A columns, okay? For example, here, they were in 6 columns. Suppose they are in, for example, and without lots of generality, we can consider they are consecutive columns. If they are not also, it will be okay, same proof. Suppose, for example, A columns, A and B rows, okay? In these rows are multiple of 3, okay? So then we can say multiples of 3 will be at most what? Because multiples of 3 can only be in intersection of B and A, okay? So how many intersections are there? Because we cannot have, for example, here, okay? Because here we don't have anything. So when we place, when we want to see how many multiples of 3 are there at most, it should be in intersection of one of these columns and one of these rows, okay? Because when we have multiple of 3, for example, here, then we say, okay, this column is multiple of 3, this row is also multiple of 3. So how many intersections are there at most? AB. So it is at most AB. Now, I want to prove that the answer is at least 11. I use contradiction. Suppose if answer is at most 10, it means what? It means A plus B. A plus B, because these A columns and these B rows are multiples of 3. So A plus B is at most 10. And we know in this case AB, maximum AB is what? When sum of two things is at most something, product is maximum when they are equal to each other if possible. So we can call this one ID as 18. The proof is not hard. So AB is when maximum when it is 5 times 5, 25 here. Because they are integers, it's easy to check. For example, 1928. 5 is maximum. So we can say this one, AB is maximum 25. Multiples of 3, number of multiples of 3 were what? 27. So we've concluded that 27 is less than or equal to 25, which is contradiction. So we can say what? We can say answer should be at least 11, and we proved it. By here, when you find this example, you can say, okay, answer is 11. You don't need to prove this because it is not used somewhere exam. For the full solution exam, you will lose at least 80% of the mark if you don't prove this part, okay? So it was problem 16 because the difficulty of each part is important. Finding example is not hard. This part is a bit harder. So that's the reason, for example, 80% of the mark will be this part. If, for example, it is in a full solution exam like BMO1, BMO2 for UK or USAMO, and this part will be around 20% of the score. In USAMO problems, we had some problems related to considering range. I can tell you as homework 14, homework 15. I released all solutions of USAMO, USAJMO. You can say in USAJMO and USAMO 2023, we had similar problems, and in those problems, we should consider range. If you want to learn how to solve them, or easier problems, or anything like that, or want to learn more ideas, as I said before, feel free to send message to my WhatsApp number in the description. Problem 17. A chess king is said to attack all the squares one step away from it, horizontally, vertically, or diagonally. For instance, a king on the center of a 3x3 grid attacks all 8 other squares here. For example, if king is here, it attacks how many cells? 1, 2, 3. If king is here, it attacks how many cells? 1, 2, 3, 4, 5. Okay. Suppose a white king and a black king are placed on different squares of a 3 by 3 grid so that they don't attack each other. In how many ways can this be done? Okay, so for this problem, we should use again casework. I think it's the third problem of this year that can be solved with casework. So as you can see, casework is so much important in AMC 8, 10, 12, AME, and a bit in USUMO. A small example is more useful in USUMO and USAJMO. If you see my videos, you can see USUMO 2023. I released all solutions. Okay, so here I use casework, and I say, okay, I use casework of what? White king. If white king is here, then we can say it attacks how many cells? These cells. But the problem says what? They shouldn't attack. Okay, so how many cases are there if you have here? For next one, it can be here. If white king is here, black king can be here, here. 5 options. So we write 5 here. Similarly, all corners are 5. If we place this white king here, black king can be this here, 3. So 3 options. And this one 3 options, 3 options, 3 options. Black king is here, white king is here. Sorry, for black king, we have 0 option. So how many cases are there? 4, 5, 5, 5, 5, 4 5s plus 4 times 3. 4 times 5 is 20, plus 4 times 3, 12. So the sum will be what? 32. And the answer is 32. Maybe you ask, should we divide by 2 or not? We shouldn't, because one of them black, one of them white, and we considered only cases of white. So if we consider 2 blacks, and again you consider that they can attack each other, then you should divide 2 at the end. Because, for example, when you say 5 here, you mean if it is this one, you consider this one. And when you say 3, you consider this one white here, black here. So when they are black and white, you should consider both of them. But when they are black, it will be same. And you should divide 32 by 2, which will be 16. Now let me tell you a homework that you can solve exactly by this idea. Okay, as homework, you can solve this problem. Homework 17. Let me check. Yes, homework 17. You can solve this one for 8 by 8 table. Okay, again, you have 2 kings, black and white. The answer is what? For kings, 2 kings, exactly like this, black and white. For homework 18, it's a bit harder, but again, you can solve it the same way. 2 knights. Okay. And I explained how 2 knights attack each other. For example, if we have, let me show you for knight, the attack will be what? Okay, if we have, for example, this one here, it can attack these 8 cells in general. Okay, 1 in one direction and 2 in a direction perpendicular to that. Okay. It was problem 17. If you want to solve again more homeworks or want to learn more ideas, as I said before, feel free to send message to my WhatsApp number in the description. Problem 18. 3 concentric circles means the centers are same. At O, concentric circle centered at O have radii 1, 2, and 3. Points B and C here lie on the largest circle. So this radius of this is 1, this one 2, this one 3. Okay, the region between the 2 smaller circles is shaded, means this one. As is the portion of the region between the 2 larger circles bounded by central angle BOC, means this part, okay, between 2 larger circles, as shown in the figure below. Suppose the shaded and unshaded regions are equal in area. What is the measure of BOC in degree? Okay. Suppose area of shaded plus area of unshaded region If we consider area, AS is area of shaded, AU area of unshaded. The sum is whole circle with radius what 3. So it will be pi times 3 squared. The formula is this r squared pi r squared 9 pi. The problem says they are equal. So we can conclude area of shaded is 2AS because AS is equal to AU. So AS is area of shaded region is 9 pi over 2. And the problem wants this angle. Suppose this angle, for example, is alpha. Now, we can split into two parts, area of shaded region. This part and this part. Okay, so let's calculate first this part. This one is area of this circle with radius 2 minus area of this circle with radius 1. So it will be pi times 2 squared minus 1 squared. Now area of this part is what? Again, you can say this area minus this area, but alpha over 360 degree. Okay? Because we want to consider this portion. Times pi times this area 3 squared minus 2 squared. Okay? So area 9 pi over 2. In first step, we can cancel both sides by pi. So 9 over 2 is what? 4 minus 1 is 3 plus alpha over 360 degree. 9 minus 4 is 5. Okay? Now, let's simplify as much as we can because we want to find alpha. 5 and this, it will be 72. So 9 over 2, if we subtract 3 from both sides, alpha over 72. If we use common denominator 2, 9 minus 6 is 3. We can multiply both sides by 2, it will be 36. And we can multiply both sides by 36 and switch left hand side and right hand side or cross multiply. 36 times 3 is 108. So the angle in this problem is 108, which is choice A. There are lots of problems related to shaded regions in AME. We have in AMC we have related to shaded regions. If you want to solve them, let me tell you AME problem is what. Okay, you can solve this problem of AME homework 19 related to shaded region with basic knowledge in similar triangles by Pythagorean theorem. You can solve this problem for calculating this shaded region. If you want to solve more problems or want to learn more ideas, as I said before, feel free to send message to my WhatsApp number in the description. Problem 19. Jordan owns 15 pairs of sneakers. 3/5 of the pairs are red. Okay, so we have 15. It says red is equal to 3/5 of pairs. So 3 over 3/5 times 15 is, you can cancel 5. It will be 3 times 3, 9. So red and white will be what? Because we have 15 pairs of sneakers in total. So 15 minus 9 is 6. Then 2/3 of the pairs are high top. So we have 15. High top is what? 2/3 times 15. So if we cancel 3 from both numerator and denominator, it will be 10. Low top is what? The rest. 15 minus 10, 5. Now the problem says the red high top sneakers make up a fraction of the collection. What is the least possible value of this fraction? So it says what? For example, if you consider red high top, you can say it is a fraction, for example, x over y times 15. It says this fraction, minimum of this fraction is what? So we should minimize red high top. Okay. Now we can use Venn diagram for this problem. So idea 19, Venn diagram. Okay. So Venn diagram, it is what? And drawing diagram helps you a lot in many problems. One of them, one application, Venn diagram in this problem. So we can consider, for example, the first circle means red or green. For example, if it is red, this one means high top. Okay. So outside this high top means low top, outside red means white. And we have 15 in total. It says intersection, minimize intersection. So for example, maybe we can say, okay, let's consider this one 0. So when it is 0, so red is what? 9. So here we have 9. High top is what? 10. So maybe also we have something outside. But the number of sneakers will be 10 plus 19. At least 19, but we have 15. So it's not possible to have 0 here. So if it is 1, then here, because red should be 9, from assumption, this one is what? 8. High top is what? 10. So this one is 1, 9. So how many sneakers are there at least? Because maybe we have also outside. So 8 plus 1, 9 plus 9, 18. At least 18, but we have 15. Like this, you can increase. Okay, you can check 1, 2, 3, 4, and you can say something. You can say, okay, we have 15 here. 9 plus 10, 19. So we should calculate 4 sneakers at least twice. So here you can say 4. And then red 9, so here 5, 10, red 9 here. 10 high top, so we can say 10 minus 4, 6. 6 plus 5, 11, plus 4, 15. And red will be 9, outside that 6 will be white. 10 high top, outside 5 low top. So it is an example. And you can say it's 4, and the answer is cannot be less than 4. You can prove it easily. We can say this one is x, this one is 9 minus x, this one is 10 minus x because high top's 10. This one you can say, okay, number of sneakers is 15. Here, 9 minus x plus 10 minus x, because maybe we have also something outside. This one is at least 15. So 10 plus 9, 19, plus x minus x minus x. So x will be what? 19 minus 15 is 4. So we can say what? Oh, sorry, not at least 15, at most 15, because total number of things, sneakers are 15, so we can say x is at least 4, and we found example. So this part was again considering range. We solved one other problem in this exam with considering range, 1 or 2 problems. So this part is proof, and example, here it is our example, and it is 4. So the fraction is what? 4 over 15 when red high top is 4 minimum. So x over y is 4 over 15. So our minimum fraction is C. Okay, we can also solve many other problems with Venn diagram. If you want to solve similar problems, feel free to send message, as I said before, my WhatsApp number in the description. Problem 20. Any 3 vertices of the cube PQRSTUVW shown in the figure below can be connected to form a triangle. Let's see how. For example, this one to this one, this one to this one, this one. This is a triangle. We've connected PRU. For example, vertices PQR can be connected to form isosceles PQR. How many of these triangles are equilateral and contain P as a vertex? Okay. This is equilateral, means all vertices all edges should be equal. And one vertex is P. So we consider again casework. Okay, we solved many problems in this exam by using casework. So the length of that is what? If we connect P to Q, the length is 1. For example, suppose without lots of generality, it is 1. So the side length can be what if we consider cases? If we connect P to Q, can be 1. Okay. P to Q, S, and W will be 1. So if we connect P to Q, S, W, the distance is 1. If we connect P to, for example, V, or T, or R, it will be root 2 by Pythagorean theorem, 1, 1. So it can be root 2 if we connect P to what? R, R, V, and T. And if we connect P to U, the distance is what? You should write 2 Pythagorean theorem. You can say, okay, this one, this one. This one is 1 if you write Pythagorean theorem. This one is root 2 if you write Pythagorean theorem. Here it will be root 3, okay? So the length can be root 3 in this case. So let's see. If we want to create one, so I should connect P to 2 of them. For example, P to Q and P to S. If you check any 2K, for example, any 2 of QSW, the case will be similar to other cases. But the third length is not 1, it is root 2. So in this case, we don't have any good choice for root 2. If we connect, for example, P to R without loss of generality and P to V, as we can see, all side lengths will be root 2, so it will be good. So we have what here? You should select 2 of them from RVT with P. 3, choose 2, which is what? Which is 3. Now, if we want to consider side length root 3, P can only be connected to U. Okay? And if you connect to P to U, we should have 3 lengths, P to U and something else. But we don't have any other vertex that the distance to P be root 3. So again, in this case, we don't have any good choice. So the answer will be what? Will be 3. Okay? It was an easy casework problem, but because the cases were easy, in some problems we have more cases. Okay. And one thing, it was related a bit to 3D geometry, basic things, Pythagorean theorem, something like that. If I want to tell you similar problem, we had one problem in AMC 8, let me tell you. Okay, here we can say idea 20 Pythagorean theorem that we applied here for finding lengths, and as homework 20, you can solve this problem AMC 82018. Again, for this one, you should use similar thing. If you want to solve more problems or want to learn more ideas, as I said before, feel free to send message to my WhatsApp number in the description. Next problem, problem 21. A group of frogs called an army is living in a tree. Frog turns green when in the shade. So shade is equivalent to green. Okay. And turns yellow when in the sun. Sun yellow. Now, initially the ratio of green to yellow is what? Yellow frogs was 3/1. So green over yellow was 3/1. Then 3 green frogs moved to the sunny side, and okay, so 3 the sunny side, and 5 yellow frogs moved to the shady side. So 5. Now the ratio is 4/1. Let's write the ratio, new ratio. Green here 3, so -3 plus 5 plus 5. Okay, because 3 of the greens now are yellow, so we should subtract, but we have 5 from yellow to green, so plus 5. For yellow, we have plus 3, because 3 from green are yellow now, and 5 from yellow are green, so -5 is equal to what? 4/1. Now it says what? What is the difference between the number of frogs, green frogs, and yellow frogs now? So here it is what? Green frogs now. G plus 5 minus 3, 2. And yellow 3 minus 5 minus 2. So green frogs now is G plus 2. Yellow frogs now is Y minus 2. So it will be G minus Y plus 4. So we should find G and Y. Okay. So 2 equations, 2 variables. If we cross multiply, let's apply that. G from here, G is 3Y if we cross multiply. From here, we can say 4Y minus 8 is equal to G plus 2. So we can say, we can replace G 3Y here. So 4Y we can add 8 to both sides. It's g plus 10. And instead of g, we replace g with 3y. Again, replacement, two equations, two variables. Now we subtract 3y from both sides, so y will be 10. And because y is 10, green will be 3 times 10, which is 30, okay? And now g minus y will be what? G is 30. 10. So 30 minus 10 is 20. And the answer will be what? Will be 24. And the correct choice is what? Is E. Okay, this problem was related to translation to mathematics. And in my website, if you check mathgoldmedalist.com, it has a feature in AMC 8 2023 2022, similar problems, ideas. And in translation, you can solve similar problems to this idea translation. And if you want to solve harder problems of this type, as I said before, feel free to send message to my WhatsApp number in the description. Problem 22, a roll of tape is 4 inches in diameter, this one, and is wrapped around a ring here that is 2 inches in diameter. A cross section of the tape is shown in the figure below. The tape is 0.015 inches thick. If the tape is completely unrolled, approximately how long would it be? Round your answer to the nearest 100 inches. For this problem, let's consider, for example, this one is D, okay? And it says the tape is what if you consider this tiny length? It is 0.015 inches thick, okay? So I want to calculate volume of this, okay? So if you want to calculate volume and then divide by this to find the length. And this area is what? Pi times. Pay attention. The diameter is 2, so the radius is 1, and for this one, radius is 2. So 2 squared minus 1 squared. This one, okay, times d. It's the volume. If you divide it by what? This one. D times 0.015. Then if you consider length of completely all these things. So we know that L times D times this one, for example, omega, width is volume. So we calculate in two ways. So we can say, okay, length is this. Length times D times W is equal to this area times D, okay? So we can cancel D from both sides, both numerator and denominator. So it will be 3 pi over 0.015. We can cancel 3 from both numerator and denominator. It will be pi 0.0005. And it will be what? It will be pi over 5 over 1000. So it will be pi times 1000 over 5. 1000 over 5 is 200. So it will be 200 pi. Pi is around what? 3.14. 3.14. If we multiply, we can say it is equal to 2 times 314. If you apply these two zeros, you can get rid of these decimal digits. So it will be 826. It says what? Round your answer to the nearest 100 inches. So it will be what? If you round it, it will be 600. And the correct choice is what? Is choice E. This problem was related to volumes and something like that. If you want to solve similar problems or want to learn more ideas, these types of problems, as I said before, feel free to send message to my WhatsApp number in the description. Problem 23. Okay, for this problem, it has a famous idea that also this idea is useful in promise problem. Let me tell you first the idea is what. Suppose, for example, we have a rectangle, and I will prove this. And we connect these two corners, the size is m and n. We want to see, okay, it passes through how many squares? Okay, for example, these things, squares, this one. It passes the number of squares that it passes through them. Let me tell you something. When it is like this, okay, we consider this one and this one, okay? But we don't consider this one. I will explain completely. For example, when we have 2 by 2, if we draw the diagonal, it passes through this one and this one, okay? It should pass inside. For example, we shouldn't calculate this square because it passes only from one vertex of that. It should pass inside of the square. So number of squares on this part is m plus n minus GCD of m and n. Okay, and so much useful here. 2 plus 2 minus GCD of 2 and 2, which is 2, so we can subtract them, it will be 2. Okay, this one and this one. Okay, I want to use this to solve this problem, then I will prove this one and I will tell you similar problems of different summer camps, prestigious exams that you can solve with this idea. Okay, so let's read the problem. Rodrigo has a very large piece of graph paper. First, he draws a line segment connecting point 0.04 to 20. Okay, these 2 points. And if I consider let me draw our square is this. Then it says what? It says and colors the full cells whose interiors intersect the segments as shown below. So how many? 4? If we use our formula, it will be what? This length 4 plus 2 minus GCD of the minus 2 is 4 again, as you can see. It says next, Rodrigo draws a line segment connecting points 2000, 3000 to point 5000, 8000. So let's see what happens here. 2000, 3000. Okay, and next one, 5000 and 8000. So then it says again, he colors the cells whose interiors intersect the segment. How many cells will he color this time? So if we draw again diagonal, if we use this formula, we should find side lengths of this rectangle. So for this one, x coordinate here 5000, 2000, so it will be 3000 for vertical side. Difference of y squares 8000 minus 3000, which will be 5000. And if you use our formula, it will be 5000 plus 3000 minus GCD of 5000 and 3000. Okay, and then it will be what? It will be 8000. GCD of these two numbers is 1000 because you can factor from 1000. It will be GCD of 5 and 3 times 1000. 5 and 3 GCD of them is 1. So it will be what? 7000. Now we can say the answer is what? Is choice C. Okay. Now let me tell you similar problem is what and then prove this idea. So it will be which I told you this one idea number translation idea 20 idea 21. Okay, this one is idea 21 and number of homework is what I told you. Homework here, homework 20. So homework 21, let me tell you, promise problem is what it is for promise 2022. Okay, and as you can see, it says okay for 6 by 8, 12, 12, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and as you can see, it is exactly AMC 8 problem. Here it is for numbers, here it is for variables, M and N. And I want to tell you the proof of this. So it's important to solve these important problems, and they will be useful for your CV, applying summer camps, and these types of things. So if you want to learn important ideas, as I said before, again, feel free to send message to my WhatsApp number in the description. Okay, let's prove the theorem that it is m plus n minus GCD of m and n. Okay, so here we consider the size here is mn. Now, I want to see our diagonal passes through how many squares. So I say if I calculate number of intersections inside this, the problem will be solved. Why? Here. How many intersections do we have inside or on this diagonal? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the answer is what? 12. Why? Because look, when you consider this diagonal and you say, okay, 1, 2, 2 for some number of intersections is equal to, for example, k. Then it passes through this one, this one, this one, this one, k plus 1. Okay, so here I should calculate number of intersections is equal to what? I say, okay, when you draw diagonal, it passes all horizontal lines. We have n minus 1 horizontal lines and n minus 1 vertical lines, okay? So, number of intersections will be m minus 1 plus n minus 1, but we should subtract something. Let's see here. We know this line intersects all these vertical lines here, for example, this one, and all horizontal lines. This one, this one, this one, this one, this one. So let's see here. Number of intersections of vertical lines 1, 2, 3, n minus 1 is horizontal lines. Okay, 1, 2, 3, 4, 5. n minus 1, n minus 1, 1, 2, 3, 4, 5, 6, 7. It is 7. But one important thing here, when we calculate number of intersection in this example, it will be what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Why it is 11, not 12? Because of this intersection. We are calculating this twice, okay? So we should subtract intersections, okay? We should see how many points like this do we have, okay? If we calculate number of these, then the problem will be solved, okay? This part is, I can say, combination of combinatorics, number theory, and geometry. So let's consider this part. For example, we have a intersection like this. Okay. Now, we say, okay, suppose, for example, this length is x, or this length is x, this length is y. We know this length is what? This length is n, this length is m. By similar triangles or Thayer's theorem, we can say this triangle, let me write ABC and DE, because they are perpendicular to AD, BC and ED, they are parallel to each other. So this angle is equal to this angle, and A is same in both of them. So by two angles, we can say triangle ACB is similar to triangle AED, okay? And then I can say what? I can say x over y, or we can say what? We can say x corresponds to what? X opposite to this one, n. And y corresponds to what? Y from ACB corresponds to what in AED? Y, and both of them opposite to angle A, so m. So we can say x over n is y over m. So we can say x over y is n over m. Now, suppose that GCD of m and n is d, okay? GCD. We have one form that is so much useful. You're right. Let me tell you, it can be idea 22. Idea 22. You say GCD is d, m is m prime d, n is m prime d. Then GCD of m prime and n prime is what? Is 1. Because if they have common factor, for example, 2, then the GCD of M and N is 2D, not D. GCD is greatest common divisor, okay? So, this form is so much powerful in number theory. Now, here, I can say, okay, N is M prime D, M is M prime D. So, M prime over M prime, it is the simplest form. So, X over Y should be equal to this simplest form fraction. So I can say x over y can be n prime over m prime, or 2n prime, 2m prime, or 3n prime, 3m prime, Or if you say dn prime, look here, I can say they will be these things. For example, m prime, n prime, 2m prime, 3m prime, until d minus 1. If you multiply by d, it will be this triangle. D minus 1 n prime, d minus 1 m prime. So it will be what? Number of intersections will be d minus 1. Okay? Let me explain for this example for you to understand completely. Here, we know this length is what? This length is 6. This length is what? This length is 8. I said when we have a triangle like this, if you divide this one by this one, it is similar to 6 over 8 by similar triangles. 6 over 8 is what? If you simplify, 3 over 2. So as you can see, it is, 3 over 4 if you divide by. It is 3, it is 4. So GCD is what here in this case is 2. 3 over 4. Next one, if you say 3 over 4, this times 2, this times 2, like this one will be last one, will be 6 over 8. So you can consider this one 3 over 4. Okay? So D here is 2. We have only one point that have this property. If it was larger, then we had this form, and more. Okay? If you had any question about this, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay. Now, intersection d minus 1. So we can say now number of intersections equal to what? Number of intersections is equal to m minus 1 plus n minus 1 minus d minus 1. So we can cancel negative 1, negative 1. It will be m plus n minus d minus 1. Now number of squares that it passes through them, we said it is equal to number of intersections plus 1. Because when we have some intersections k, it passes through k plus 1 squares. So answer will be what? Will be m plus n minus d minus 1 number of intersections plus 1, which is m plus n minus d. D was what? GCD. So it is m plus n minus GCD of m and n. Now let me tell you a similar problem that is harder than this. Homework 22. Suppose we have a cube in 3D, m by n by k. Then we draw diagonal of this cube, okay? Or cuboid, let's say. Then it passes through how many squares? Find the answer in terms of m, n, and k, okay? We can use again in a similar approach, but a bit harder related to problem solving. If you want to know the solution of this or other problems or want to learn more ideas, as I said before, feel free to send message to my WhatsApp number in the description. Problem 24. Jean made a piece of stained glass art in the shape of two mountains, as shown in the figure below. One mountain peak is 8 feet, this one, and high, and the other peak is 12 feet high, this one, 12. Each peak forms a 90 angle, and the straight side, the mountain, form 45 degrees angles with the ground. The artwork has an area of 183. These parts. We can say this part, area is 183 square feet. The sides of the mountains meet at an intersection point near the center here of the artwork, h feet above the ground. What is the value of h? Okay, so here we can split this into smaller parts. Now let me minimize this. Okay, so we have these triangles, 4 triangles, 1, 2, 3, 4, and one rectangle here, we can say. So let's calculate area in terms of h. It is h. Because it is 90 degree and it is 45, so it is an isosceles right angle triangle. This one, the height here is what? Let me draw with green. This one is, let me maximize. This one is 8 minus h, okay? 8 minus h. And again, because it is 45, this angle is also 45, so this one again is 8 minus h. And this one also 8 minus h. So we can say this part is 16 minus 2h. This is h, this is h, this is h again. And we can say what again? If we draw this one, because we know it is 45. And this one is 12. This one is h. So this one is 12 minus h. So this part is 12 minus h. This part 12 minus h. So the sum is 24 minus 2h. Now I want to calculate area of this one in terms of h, and area is 183, then we can find h. So this area is what? H squared over 2. This one is what? H squared over 2. This one is what? 12 minus h times this one over 2. 12 minus h. Height times base. Base is what? 24 minus 2h over 2. Plus what? Plus this one 8 minus h height times base 16 minus 2h over 2. So we've calculated 4 triangles. Only this rectangle is left. 8 h times this part. So it will be h times 24 minus h plus 16 minus h. Okay, so 24 minus 2h, sorry, minus 2h plus 16 minus 2h. 24 plus 16 is 40 minus 2h minus 2h minus 4h. Okay, now we shouldn't divide by 2. Okay, so we shouldn't divide by 2 because here it's a rectangle. Let me draw our lines again. This one. Okay. So this one we said, this one, this, and this. Okay. So here it is equal to what? 183. Now, one equation, one variable, we want to solve this. If we divide by 2, it's 12 minus h. If you divide by 2, it will be 8 minus h squared. So it will be what? H squared over 2 plus h squared over 2 is h squared. This one is 12 minus h whole squared over 2. This one is 8 minus, we don't have over 2, sorry, because here 2 and 2 will be cancelled, plus 8 minus h squared plus h times 40 minus 4h is equal to 183. Now let's expand this part. Okay, so we have h squared. If we expand, we can say a minus b squared. We should use that identity. So let's apply. Here, h squared, first one, 144 minus 2 times 12 times h, 24h plus h squared. Plus 64 plus minus 16h plus h squared. This one. Next one is 40h minus 4h squared is equal to 183. H squared, h squared, h squared minus 4h squared. So 3h squared minus 4h squared, which will be h squared. 24, negative 16, negative 40, plus 40. So we can cancel these 3 terms. 144 plus 64 is what? Plus. Here, sorry, minus h squared. 144 plus 64 is 84208 is equal to 183. So we can move h squared to right hand side. So 208 minus 183. 8 minus 3, 5. 10 minus 8, 2. 1 minus 1, 0. So h will be what? H will be 5. And the problem wants what? The problem wants h. So the answer is choice B. Okay. We have lots of problems that you should split into smaller parts. So we can consider the idea here. I told you idea 20. Idea 23. Split into smaller parts. We have also similar problem in AMC. I can tell you this one as homework. How many homeworks did we have? Homework 22. Homework 23. We had similar problem in AMC 10 or 12, 2023 last AMC. Let me tell you exact problem is what. Let me copy and paste the problem. Okay, this problem is AMC 10A 2023, problem 24. You can solve it with similar idea. I released the solutions of this problem exactly right after AMC 10A exam. We can use that, and it's similar to this one, but so much harder, okay? But the ideas are same. Again, we should split into smaller parts and solve the problem. Okay, idea 23 and homework 23. Okay, last problem. Problem 25. A small airplane has 4 rows of seats with 3 seats in each row. 8 passengers have boarded in the plane and are distributed randomly among the seats. A married couple is next to board. What is the probability there will be 2 adjacent seats in the same row for the couple? Okay. So these two, we don't consider these two in these 8 passengers. So for this one, again, we want to use casework, and I think it's the 4th problem of this year that we are solving with casework. How we want to apply casework? Okay. So I want to calculate bad cases. So I want to use complement rule. Okay, idea 23, 24. Complement rule. I want to calculate bad cases. Bad cases means what? Means we don't have 2 adjacent seats in the same row for the couple. Now I want to use casework. I consider these 8 passengers. For example, in each row we can have at most 3 passengers. So how many threes can we have at most? So we want to calculate number of bad cases, okay, or probability of bad cases. So can we have 3 threes? No, because then it will be 9, but we have 8 passengers. So if, for example, in 2 rows we have 3 threes, and what is left? 2. If we consider, for example, 3, 3, 2, then this case is not bad, because if, for example, one row is 0, then we have 2 adjacents. So when we have 2 threes, the next one should be 1, 1. Okay, if you have 2 threes. So we can have only what? 1, 2, 3 in each row. If you have 1, it should be in the mid one, because we are calculating bad cases. If you consider here, then these two are adjacent. Okay, if you have 1, it should be in the mid one. If it is 2, all cases are good. This case, and this case. We have 3 cases. And if you have 3, okay, this row is bad for the couple. But if you have 0, it's not good here, because then we have 2 adjacent ones. Okay, so in each row we have 1 or 2 or 3. So we want to calculate number of threes. So if you have 2 threes, it will be this. If you have 1 3, then we can have 2 and 1 only because of this. So it will be only what? 2, 2, 1. 3, 2, 2, 1. We don't have any other cases. If we don't have any 3, so one case is possible. 2, 2, 2, 2. This problem is related to counting. You should solve some similar problems in counting to get good at this. If you want to solve similar problems, harder problems to get good at counting, as I said before, feel free to send message to my WhatsApp number in the description. Okay. So 2 threes. I say what? Which 2 rows have 3 passengers? So we should say 4 choose 2. Okay, for our 2 threes. Then in those 2 rows, for example, if you select this row and this row, it will be like this, like this. Then in next 2 rows, we should have 1 passengers, and they should be in the mid one, so it will be unique. So the answer will be 4 choose 2 times 1, which is what? 4 choose 2 is 6. So this case is 6. Now let's consider next case. 3, 2, 2, 1. So I can say which row has 3 passengers. For example, you should say 4 choose 1 for the 3. Then, and we have passengers like this. Then for 2 twos, we should have, for example, this one and this one. You say, okay, 3 choose 2 for 2 twos. Now, here, when we want to place 2 passengers, it can be here or here or here. 3 cases, okay? So 3 times 3 for this one and this one. Then here we have one passenger, it should be in the mid one times 1, okay? So, for example, it can be like this one and, for example, this one. So it will be 6 times 3, 18. 18 times 3, 54. 3 times 54 will be what? Will be 162, okay? Oh, sorry. 4 times 3, 12. 12 times 9 is 108, okay? So let me erase these things. That's true. Now 2, 2, 2, 2. For each of them, we have 3 options. This one, or this one, or this one. So it will be 3 times 3 times 3 times 3 for each row. So it will be 81. Okay, now let's add all these numbers. 6 plus 108 plus this 1 plus 8, 9 plus 6, 15. We have 1. 1 plus 8, 9. It will be 9 and 195. Okay, now we have 195 choices for selecting seats. Okay, so we can say 19. If we want to calculate probability of bad cases, it will be what? You can say 195. Then in this 195, we can place the passengers in 8 factorial ways. Now, what's the total number of cases? You can say 12 choose 8 times 8 factorial. Okay, so we can cancel 8 factorial from both sides. 195, and here you can say 12 times 11 times, because it is also equal to 12 choose 4. So when you have 12 choose 4, you start from 12 and you should write 4 numbers like these: 12, 11, 10, 9 over 4 factorial. So it will be 195. If it multiply both numerator and denominator by 4 factorial, it will be this, and we write 4 factorial as 4 times 3 times 2, then over 12 times 11 times 10 times 9. Now 4 times 3, 12. And you can cancel 2 by this, 5. 5 by this, it will be what? 3 times 5, 15. 45, 9. Now we can cancel 39 and 9 by 3. 13 and 3. So it will be what? 13 over 33. Now, probability of good cases then will be what? Will be 1 minus 13 over 33, which will be 33. 33 minus 13, which will be 20 over 33. So our answer will be, which choice? Will be choice C. As homework, you can solve this problem as a similar problem. You can solve this one as homework AME 1 2023, problem 1, homework 24. So here we've considered these ideas and 24 ideas, 24 homeworks. We've considered all problems, and you can try these problems. You can try homeworks. Let's review them, these ideas, these things for each problem. For most of the problems, I said some problems from SUMAC, from Promise, important and prestigious summer camps. I told you some ideas in each part, general ideas, background ideas. If you want to learn more ideas, want to get good at solving these types of problems, want to improve your problem solving, and you want to prepare for AME, AMC 8, 10, 12, USAMO, IMO, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, thanks for watching this video. Have a good day. Bye.